everybody, this is the first video in a series on unit testing and test-driven development with xUnit and .NET Core. I'm Benjamin Day, owner of Benjamin Day Consulting. I'm based out of Brookline, Massachusetts. My website is benday.com. And yeah, enough about me. Let's dive in. Like I said, this is the first in a series of videos on unit testing with xUnit and .NET Core. This first video that you're watching now is going to talk a little bit about the basics of unit testing, starting off with what is a unit test, and also what is unit testing as a coding practice. Along the way, I'll talk about why you care about unit testing. And since this is about coding and writing software, I'm going to do a whole lot of demos, including demos about code coverage, and also how unit tests can help you to refactor your application code. Eventually, in this series, I'd like to get into design patterns for unit testability and cover things like model view view model view controller, repository, adapter, and strategy. Those items will come in later videos, but first I'm going to just cover the basics. Moving on. So first off, the big, huge, giant question, what's a unit test? If you write an application, someone somewhere is going to have to run the code and see if the code works. Whether that's you or whether that's a QA tester, you'll need to know that your app is working. Now, the idea of a unit test isn't all that fancy or exotic. You're just automating that testing process. Instead of relying on a human to check if the application works, you'll write little chunks of code that tests if your code works. Those chunks of code are called unit tests, and they help to verify that your app code is actually working. When you're writing the code for your application using tests, it's a good idea to think about coding in two pieces. The first piece is the test code. The automated unit tests, or integration tests. This is code that's really probably only useful on your development workstation or your build server. In all likelihood, you're probably never going to deploy the tests. On the other hand, you have your system code, the system under test. This is the application that you're writing, and this will definitely get deployed somewhere. So thinking of the two pieces, the test code validates the application code. The tests are helpful during development. The application gets deployed. Now, you might have heard the term test-driven development. That's commonly abbreviated as TDD. So what's the difference between unit testing and TDD? In my mind, not a whole heck of a lot when it comes to the code, but there could be a lot of difference as it relates to how you actually write your code. Okay, TDD, also known as test-driven development, is a mindset and a process. The idea is that the test code comes first and that the application code follows along afterwards. Let's say that you've been tasked with writing a new feature. This means that you're not only writing the feature, but you're also writing the test for this feature. The feature code is called the system under test. It's often abbreviated as SUT. At a minimum, you'll be writing one unit test method per public method on the SUT. You'll validate the outputs from the SUT using assert methods, and that's the process at a super high level. If you're looking to read up on test-driven development, the book to get is Test-Driven Development by Example, written by Kent Beck. The big, huge takeaway from this book, especially as you're getting started, is that you should never write a single line of code unless you have a failing automated test. Tests come first when you're working in the TDD mindset. I'll tell you from experience that test-first approach feels super strange when you're just starting out. So how do you get started? This is going to sound obvious, but the first step is to get an idea for what you want to develop. I know you're probably thinking, well, of course I need to know what I want to develop before I develop it. Well, one of the things I started to notice as I got going with TDD was that I used the process of developing the application code to actually figure out what the feature in the application was supposed to do. I'd work that way, and then I'd be surprised when the application code came are super messy. TDD helps you to keep yourself honest about what you know and don't know. So start by making sure you understand the problem. Next, you should come up with the ways that the code can succeed and the ways that the code could fail. So think up success and also failure scenarios. Once you have that list, they become your test cases. As you get going, you'll probably discover more test cases that you'll need or want to add, but this list will get you started. And remember, the most important bit, write your test code first. Let's break that process down into a little more detail. First, you'll write the test code. This will start with the setup logic for the test scenario, then you'll call whatever application logic you're writing, and then you'll validate the results. Next, try to compile the code. I can virtually guarantee that the code won't compile. And the reason is, well, duh, there's no implementation. Next, write just enough code to make everything successfully compile. Try not to write any implementation for your feature, only write just enough structure so that the code compiles. Now that it's compiling, run the test. Once again, it's going to fail. Probably because in step number 3 you put in a bunch of code that said throws not implemented exception. Running the test and having the test fail is essential. If it's passing at this point when you have no implementation, then there's no way that that's right. The test has to be bad. Always start with a failing automated test. Next, write just enough code to make the test pass. Don't overbuild. Don't write too much code. Just enough to make it compile and have it pass. Once the tests run and pass, you're done with that feature or test. Check it into version control. You're going to definitely be looping through steps 4, 5, and 6 at least a few times. Write a little code, see if it compiles. If it compiles, run the test. If it's failing, write some more. When it's passing, stop and use version control to take a snapshot of that known good working and tested code. After you've checked it into version control, you can refactor your code. Try to clean up duplicate code or things that are messy. The unit tests are what help you to safely do refactoring. If you change something in the code, the test passing or failing immediately tells you whether your changes are good or bad, passing or failing. If the code gets well and truly horked, you've got that version control snapshot. Just undo your changes and you're good again. And then you move on to your next test case and repeat the whole process again. But the key here is that you're starting with the test code first, and that the test code should always fail before it succeeds. The typical unit test method has 3 sections or phases to it. Phase 1 is the arrange phase. This is where you'll set up the test case. Basically, set up the scenario so that you're ready to make the call to whatever you want to validate. Then you have the act phase. In this phase, you'll call whatever application code you're trying to run and validate. And finally, the assert phase. In the act phase, you called the action you want to test and got back the results. In the assert phase, you verify the results to make sure that you got back what you expected and/or that the state of the system is what you expected it to be. This series of demos that you're watching are going to be using the xUnit.net testing framework. There are lots of testing frameworks to choose from in the .NET world. The big 3 are xUnit, NUnit, and MS Test. I've used all 3 at various times in my professional life. They all basically do the same thing, but these demo videos focus on xUnit.net. Anyway, enough jabber-jawing. Let's do some demos of this stuff. The first demo will be writing a calculator using test-driven development. Stay tuned.